It gives us both great pleasure to welcome Laura Bell to the stage. Laura is the founder of SafeStack Academy and has had a long career in information tech and information security. And I can't wait to hear what she has to say to us all this morning. So everyone give a giant round of applause to Laura Bell. Thank you so much.
Okay, good morning. Now, I'm doing a little bit of a sound test here because I wear hearing aids, and so I need you to raise your hands if you can hear me at a level that is comfortable for you. Fabulous, because I can't actually judge what it's like for you. All right, so, hi. How's it feel to be doing talks in Hogwarts? I'm very excited. But I'm here today not to talk about how excited I am about old architecture, because I live in the far north. We don't have architecture. We just, we have subtropical things that fall down occasionally. I'm here to talk about security. Specifically, I'm going to talk about what you can do about security, and not just you, but everyone you work with and everyone they work with. In fact, I want us to become the biggest security team the world has ever seen. And if you've met me before, then you'll know that I sort of do this. I like doing big things. Why go small? For those who haven't met me before, I've done a few things. Most of it's not that exciting. I've worked in some cool places. I've done some cool things, but I'm very mission-driven. And my mission in the world, if I get to do one thing before I go on to, live on a farm, it's going to be that little ingredient that's scribbled on the side of a page in a recipe book. You have no idea why it got there. You just know that the cake doesn't work without it. And that's what security is. It's that little ingredient that we slide into everything that makes it better, but in a way that we don't really need to focus on at the end. The best security isn't really noticeable. It just makes us stronger and better. A little bit of a disclaimer here. I'm going to use COVID themes and mechanisms because it helps to understand what we can take away from what has been a very, very nasty time for many of us. But if those of you who've been affected personally or your family have been, please note that in no way at all am I undermining what this has meant for you. So if you have any concerns afterwards, please do come and chat to me. So 30 million, where does that number come from? Well, that's the number of software developers in the world right now. Now, that's the number who write code. It doesn't include all of the other roles. Raise your hand if you're not really a developer. I know there's a few of you here because you told me outside you weren't really developers. Now, people who just raised your hand, please stop raising your hand to that question. You are absolutely key to this puzzle. 30 million might be what we call the development community, the people who write code. But code doesn't get written on its own. Big systems don't exist because people wrote some Python. They exist because we designed something. We engineered a solution. It takes lots of us. And it's going to take all 30 million, or more than that. In fact, this is growing at a rate of 6% a year. It's 1.2 million people a year enter software development as a career. That's a lot of people. Imagine if each one of those people gave an hour of their time in the year, just 1 hour, it's 30 million hours of effort on security. That's a lot of security that we can get done. So, a little bit of a disclaimer. The world is not as mature as we think. Raise your hand, those in the room who think your security and your organization is awesome, we're rocking it, we're doing it super well. You literally work for Google. So, yeah, okay, the rest of us, like to call humans, I love you, Katie. It's not like that, right? Security, we know mostly that we need to do it, but we're in what we normally call fragmented exploration at best. We're doing some bits and pieces. Sometimes it's coherent, sometimes it's not. And some of us, we're just emerging. We know that this is this big monster and we need to think about it, but actually, to be honest, that sounds really hard and overwhelming, so maybe we'll just do something else right now. And that's okay. Because if we plan a world for thinking everyone is this top one, this cutting edge, then actually we overlook some really fundamental things we can do for all of us. Now, while everyone else was, baking sourdough for the last 3 years, my little tiny company, SafeStack, we dropped 94% of our revenue overnight, as you do, which it happens in pandemics, who knew? So instead of sitting around making sourdough, because I'm a terrible baker, I started looking at what was happening, and the security nerd in me got really, really curious, because what I was seeing was a physical representation of what I did all day long, every day. I was seeing the propagation of a high-risk thing through a network, albeit that network was people. I was seeing the preventative and controlling steps that societies, not just in New Zealand but around the world, were putting in place to respond. Detective controls, preventative controls, response. I was like, oh my goodness, the world gets me. I felt for the first time in my life that the world actually understood what I did for a living, albeit it had to involve masks and sneezing a bit. But that was okay. And so I sat and I thought, and I was like, well, how can we learn from the COVID situation and apply it to securing our applications? So I'm going to take you through the 5 things that you may or may not have been even aware were happening in the COVID response, and how you can adapt that to be about AppSec. And so you can make your applications even better. Raise your hand if you work on an application you think is fairly sensitive. You know, there's some data in it that somebody else might want. Good, I'm glad that most of you are raising your hand. Raise your hand if you're like, no, my app is not worth anything to anyone. Everyone else is employing. It's fine, there's lots of jobs. Every application on the planet needs this, and I'm going to explain why in a second. So let's start with tracing. In COVID times, we had our COVID tracing app, and many of us still have it on our phones, either because we don't delete things or because we're still using it, and that's great too. And I'm going to, raise my hand and salute the people who got this out the door. Any of you who've tried to deploy something at this kind of scale, in this kind of time frame, know that this was not easy. So ignoring all of what the media said, great triumph. So can we raise our hands, please, to the people behind the COVID response app? This was a phenomenal piece of technology, and it allowed us to trace. It allowed us to understand our position in the storm that was COVID when we interacted with other things. Now, as humans, we tend to think of ourselves a bit like this old kind of like Galileo-style astronomy diagram. We tend to think we're the center of the universe and that we can see everything we connect with and that it's all fine. But when we start thinking about risk, when we start thinking about the importance of tracing in it, in COVID and in our software stacks, we're not the center at all. In fact, it's not as simple as this. This makes it look like the entire world is very easy to understand and see. But it's not. It's not at all. Now, this isn't Python, this is Node, but that doesn't matter. This is a rendering of the interconnectivity between packages for one package. So it starts with the Browserify module in NPM, and it takes into account the literally tens and hundreds of connections, first degree and second degree, between packages in our ecosystem. Raise your hand if when you write code, you inherit packages to help you do your job. There's at least one of you sat in the room going, no, I write everything from scratch. And that's good for you. But 99% of our software is not your software. It's your software plus other people's software, plus the software they then inherited. We are a connected ecosystem. Now, think about this in COVID terms. If this was a map of people, then you can start understanding why we need to start thinking differently. Because if this was a COVID graph of our contact tracing and Browserify was the first person, then every module that Browserify touches needs to be informed if something bad happens to Browserify. We don't do this well at the moment. In fact, for many of us, we don't even have a clue about all of the packages that we have ourselves or that we inherit from second-degree connections. Now, this is a grab from libraries.io, which is an amazing resource, and if you run an open source project and you want to get updates on when packages are available on every obscure language you can imagine, it's a great place to go to. As you can see, this isn't just about Node. It's very easy to say Node, well, NPM, yeah, it's all a bit dodgy. But it's not, right? Every single package management system has similar problems. We have lots of packages that we inherit, and that code comes in various different forms and has different qualities about it. Some of it's really good. Some of it is less good. Some of it's frequently updated. Some of it hasn't been touched in years. So if we look at Pippi, we've got 446,000 dependencies, as opposed to the 2.3 million that are in NPM. Does this mean that the Python ecosystem is better because it has less dependencies? Raise your hand if you think that's better. Oh, people are like, it's a trick. I'm not raising my hand. Because it's a catch-22, right? People, you sit in a room of .NET developers and they'll be like, yeah, well, we have way less packages, and so we're better. I'm like, no, but your packages are huge. When you inherit one of them, it's thousands of lines of code. At least in NPM, it's 7 lines of code, 3 emojis. The trouble is, it doesn't matter which ecosystem you're in, because actually, we're all in all of these. The systems we build and we use every day are made up of all sorts of technology strung together in a big connected ecosystem. And this introduces what we call transitive risk, and it's what you understood in COVID as the impact of you having contact with another individual and being at risk from illness because of that. And your systems are full of transitive risk. The most important thing we can do for security is map this, is to understand where our software sits in relation to others, so that when bad things happen to us, we know who to contact. And when bad things happen to things we use, we know when to respond. But it's really hard mapping the transitive risk of your software, because it's not easy. Very few of us actually work in one language anymore. Very few of our systems work in isolation. Unless you actually have an air-gapped system, it's not really a thing. And so this becomes a very challenging thing. If any of you are like proper data nerds and want to have a go at visualizing, do the visualization. Go grab D3 or whatever and map it. It's a beautiful project. Now, the problem this introduces is supply chain attacks. Now, that's the idea that I, as an attacker, am very lazy, or, as business people like to say, ruthlessly efficient. And as such, I like to have economies of scale, which means that I'm not going to attack each one of you individually, customizing my little plan in some kind of Hollywood caper. No, screw that. I'm going to find the thing that connects you all, and I'm going to do it once, and I'm going to do it really, really well. So, am I going to come after your custom Python? Probably not. But if I know that a package in your ecosystem is used by 20% of the ecosystem, I'm going to have a crack at that. Because do it once, do it well, profit for much, much longer. And that's how you need to think of things. It's not a problem that you use this software. It's just you inherit risk by doing it. And attackers aren't going to come after you if they don't know who you are, if you're not going to be worth the investment of time. Now, Heroku, raise your hands if anyone uses Heroku. Like, hug ops to the Heroku team, you've had a terrible year. Heroku had a breach this year that has been a really good example of why this matters to us and why tracing is really important. Heroku, according to their own website, hosts 13 million applications and have 9,500 paying customers. Now, when you think about this supply chain attack thing and compromising something like Heroku, you start to understand the real impact of what we're talking about. So just taking 3 of the case studies off their own website, compromising Heroku, so getting access to private keys, being able to access environments and the secrets stored in them, gave you access to Cisco GoToMeeting. Now, nothing important is ever said in a video chat, because we just don't do business by video chat, right? Yeah. DNS simple. DNS has no impact on the security or operations of our systems in any way, so that's fine. No risk there. And the final one, ThinkMD, a healthcare platform. That data is certainly not important or high risk. And this is 3 out of 13 million applications. Now, if you put your attacker hat on, this is good business. So the future of security isn't going to be about your code. It's important that you write good quality code, that it's accessible, performance, scalable, all of those things. But it's also really important that you understand the risk you inherit from all of the other technologies you use. Now, how many of you have a checklist for deciding what technologies you build your technology out of? Oh, Tom. There's always one, and it would be you, Tom, and I love you dearly. You can share yours with the class afterwards. Most of us, however, being quite candid, how many of you just look at the number of stars it has? A couple of you. How many of you are like, oh yeah, well I saw it in that conference talk once, and they were American, they looked like they knew what they were doing. Yeah? The reasons we choose software components, we like to think it's science, and it's not. It's subjective. If it's well marketed, it has a good name, the code base looks okay. What I'm going to say to you is, as well as knowing your connectivity, I want you to know why you're choosing a library and that it's safe to use. Now, I will release a slide deck afterwards. You're more than welcome to pilfer it and use it as your own content. But there is a set of questions I would love you to ask about every technology you use, so that you can at least say, am I inheriting bad stuff to begin with? It can't stop you later. There might be problems down the line. But it's the checklist you can use right away today. It's going to cost you nothing. Buy no tools. That's going to help you choose good components. So when you inherit things, it's not going to cause you pain. So how can you, part of the team of 30 million, get on with tracing? Firstly, know your stack. Map it. Understand transitive risk for you. Choose your technologies consistently, and then keep up to date with security news. Now, that's not as much fun as it sounds, but find ways to do it. You have an active community here, so share that. Next up, distancing. So, partially because I'm an introvert, but also because it was quite nice. I actually kind of liked the distancing part of COVID. It was quite nice staying in my own little bubble and having my own little world. That wasn't for everyone. And whether you're here or whether you see this later from the people who are connecting remotely, this concept of staying away from each other because the spread of risk, the spread of COVID was lessened by it. Or masks, the lovely masks you're wearing today. Apologies for me not speaking in a mask. I wear hearing aids, and at the moment I've got hearing aids and then microphone. I can't do mask on top. It's just too much. My ears, it's heavy. I want us to use distancing to reinforce our software architecture. Raise your hand if you consider yourself a software architect. Now, raise your hand if you didn't raise your hand, because you are all architects. An architect doesn't need to be someone who has a fancy architecture qualification. It's anyone who designs things. It's anyone who thinks about a system and then thinks about its implementation and links one to the other. And being a security architect is about considering security as part of that design process. Your systems don't look like this. They don't have a polite edge around them where everything on the outside is safe and everything on the inside is all protected because of the outside layers. Your systems don't even look like this. There is a degree of element of chaos in the way we build software, in the way that we connect between things. And so as a software architect, as a security-focused software architect, your job is to understand what does it really look like and find the controls that you can put in place to keep it safe. Now, if I go to the real world for a second and talk about how this works, let's imagine for a second that the nice gentleman at the back who's got the camera, he's going to be a bear. Hello, bear. And we'll pretend we have a giant tub of honey up on this stage in the middle. Now, in our cliched, stereotypical situation that massively, massively insults all bears, we're going to assume that the bear wants to get to the honey. Now, raise your hand if you have an idea of how we can stop the bear getting to the honey. Blue jumper, what are we doing? Make the route longer, absolutely. I love how nobody's like, why is there a bear in a conference hall? The bear is very lost and confused. Yeah, we can make the path longer. We can do things like put bear traps in. I'm not a big fan of this, but we could do this. We could put cameras in so that we could just come and move the honey at the last second. Or we could send in the security team. I've never been at a conference with a security team before. This is very exciting. We can go and tell them about the bear. I'm sure that's in their playbook. So we've got controls we can put in place as architects to build a solution that stops a threat, a bear, getting to the thing of data. A thing of data? Oh, Freudian slip. Honey. Yes, definitely was an analogy for data. Now, we call these preventative, detective, and responsive controls. And the idea that we're getting to here is the idea of zero trust. I want you, as security architects, as software architects, to assume that nothing in your system can be trusted, that every bear is evil, that everything that could go wrong will go wrong. It's actually very freeing. Because once you go, actually, everything is chaos and we can't control it, you can start putting things in that reduce the likelihood of bad things impacting you. Now, these are the kind of controls that we're talking about in software. We're not talking about bear traps and cameras. We're talking about encapsulation, encoding, sanitization. We're talking about code review, testing, logging. All of these things that you're probably used to doing bits of, but all we're saying is very consciously look at your architecture and place these things in. and assume that you need to have a spread of these in different places so that if one control fails, other ones pick it up. And that's all security is. It's not a fancy box that you buy for $100,000. It's tiny, minute changes that keep your things of value away from the things that keep causing them harm. So in our COVID world, that's a mask and 2-meter distancing. In our software world, it's this. Now, there's some nice things you can do free of charge again. So this diagram here is an open source threat model that is part of OWASP. There are parts of OWASP you've probably never encountered or touched, and I'm going to show you, encourage you towards them today. This is an example threat model, an architecture diagram for a payment system. So if any of you write a payment system, there are well-documented, well-defined, secure architecture designs you can go and use today. And that's quite nice, right? Who wants to do stuff twice? In fact, let's talk about those bits of OWASP you want to go. So OWASP Threat Dragon, great project name, has a cute logo. The Threat Modeling Cookbook and the Threat Modeling Manifesto are all big collections of free, open source threat modeling guidance, education, and sample architectures you can go and use today to make sure that when you design your next piece of code, that it keeps that distance between the things that are going to cause you harm and the things you want to protect. So design for security, embrace your security architect self, and bring it in little steps throughout your architecture. So testing, that's up next. Raise your hand if you know your team doesn't do as much testing as it would like to do. Raise your hand if your team does very little testing, and you will get to it one day. It's okay. You know, the thing about security is we very rarely stand up to each other and go, hey, actually, we suck at this. And one of the most powerful things you can ever do when you're facing something that's really hard is admit what you're doing and where you've got vulnerability and where you're not doing things at all. And testing is one of these areas. We're pretty bad at it because it's not really that exciting unless testing's your jam. Now, testing, we know about. We've done a lot of testing in the last 3 years. Many of us did tests this weekend just to attend here. And testing was a great way to confirm a problem. It doesn't say, it can't confirm the negative, you can't say you're definitely fine in every way, but it could confirm a very specific problem. Now, this is a software development lifecycle. Now, I really don't believe that testing belongs on its own just at the end here. I want us to move testing to be all the way through, like we did in COVID. Testing wasn't the thing that we did at one point. We did it all the time. Any time there was something we needed to check. Now, there's 2 types of testing we very commonly do in the security side. We do vulnerability assessment, and we do automated testing. Now, if we put these into the COVID world, think about your vulnerability scanning as that thing where if you went to Briscoe's and somebody at the door is checking your temperature on the way in. They're looking for a symptom of something. It's not going to confirm whether you have COVID or not. It's just going to say you've got a fever, and that's probably not a good thing. And it's something we can do easily and quickly again and again and again. Automated testing, on the other hand, is looking for the exact set of symptoms that get you to a very specific problem. And our world needs both of these. So doing a RAT test, for example, or doing a PCR test is more in these proper testing. So we know that those tests are very specifically picking up COVID. Now, our testing at the moment, a lot of us, despite a lot of very good conference talks, do a lot more manual testing than we do anything else. That manual testing, particularly when it comes to security, is really painful and can mean that your security work ends up very separate to your core team. I'm trying to encourage you to bring testing, particularly in the security space, more into your day-to-day. So bring it parallel or integrate it into your CI/CD pipeline. Now, if you do bring it in, remember that not all security tools were built for CI/CD sort of pace. And if you break your build and suddenly make a 6-minute build turn into 6 hours, nobody's going to be your friend. But at that point, it's a great opportunity to go, well, what just caused this to balloon? Do you know the best people to write the future generations of security tools? You lot. Because the people who wrote the current generation weren't software engineers. They were networking nerds and security nerds, and they've done a great job. But you can do better, and that's my challenge to you. So when you are choosing a tool, there's a whole set of things you can get from the slides afterwards. So when you're going to pull these things into your life cycle, check these out. Check out what you can do. Make testing something you do all the time. So vulnerability scanning for looking for those symptoms that something's going wrong, and testing itself for confirming very specific issues. I also want you to consider your legacy projects in this. How many of you have code in your world that doesn't get built anymore? Because, well, it's live now, so nobody's touching it. Yeah, we're going to talk about that a little bit now. Because the thing we don't talk about in security is the code it's not dead. It's just doing its job. It's just kind of happily being. And that's tricky because those systems aren't getting a CI/CD pipeline run against them. There's no testing. There's no architecture reviews going on of them because they already exist. And this brings us to prevention. Oh, that's very light on the screen. I'm going to fix that slide afterwards. I love these posters. I think we had some of the nicest posters for COVID in the world, but I'm slightly biased. In COVID times, prevention was mostly around vaccination. Not here to talk about the politics of vaccination. It's a great thing, and the world is complex enough without unnecessary debate. But what we're talking about in prevention for software is something similar. Preventing bad things happening, which most commonly is patching. Raise your hand if you in the audience have a package in your stack that is out of date and should have been updated some time ago. Yeah. Now, we all know theoretically we should patch all the time and keep all of our software up to date, but we also all know but never talk about why we don't do that. Because it's not just that we don't have the time and we're busy, though that is true. It could be that it's a legacy project and that updating that package is going to break everything, and there's no one in the organization who actually knows how this thing works anymore. It could be that it's a breaking change because the security change was rolled in with massive other changes. Like security patches, we're a byline at the very, very bottom of 17 other changes. That's not a small fix, and your team aren't going to thank you if you suddenly just roll in all of this new stuff just because of the security thing. Or there's no patch available. If you're using technologies that aren't as well maintained, particularly that aren't in well-supported or funded open source projects, this can be really hard. So while it's fascinating to me that you should patch all the time and there's tools for that, go do that, it's more important to me that you have a plan for these situations. For the systems you cannot update, that you don't know how to update, that you don't know where the source code is for it anymore. I'm not judging. The world is like this. So what can you do in the situation? Well, we can fork and fix. How many of you have forked something to fix it because you're like, I'll save it myself? Yes, the Batman mode, love it. How many of you then pushed that change back upstream? I love Python conferences because some of them are like, yeah, gonna help the world, and it's amazing. And some of you are quite honest like Chris, and he's like, yeah, sometimes, maybe. Forking and fixing can be really powerful if you know what you're doing, and it can be incredibly dangerous if you don't. And if you don't push it back upstream and you go out of line for all subsequent changes, you are creating a world of pain for yourself. But what if it's the only option you have? We could ignore it, YOLO. What's the worst that could happen? Well, actually, sometimes the worst that could happen is not very bad at all. And, it's not a popular view in security, but sometimes the answer is don't fix it, monitor for it. See what's going on. Or we could change library or language. Tell you what, let's get rid of all relational databases and replace them with something else. Like Cassandra. We'll do that. Now you have other problems. It's not just about the new technologies. The new technologies have their strengths and weaknesses. But whenever we change library, we change the skill set we have in the team. We change the complications we have in support. All of that documentation that we had, if we had any, is now out of date. It's hard. Have a plan for the software that you cannot just patch, because it can't be ignored. Having a plan for the edge cases is really the future of software. I wrote my first code that went into production when I was 17, and it was in COBOL, and it was the Inland Revenue in the UK. Since then, I've written horrific real-time C++, probably the worst enterprise Java that anyone has ever seen, and there is Python code that I'm very sad has now been expunged off the internet. But that's our careers. We write well-intentioned, well-designed software with the skills we have at that moment in time, and then it lives long beyond that job. And so you need to plan to keep it secure for its whole life, not just your life as a software developer. So define a patching policy, and then more importantly, define what you're going to do when you can't patch, and those systems that are particularly at risk. So response, my favorite part, kind of. So if you ended up getting COVID in the early days, you will have gotten flyers to your door, a bit like this, if you weren't sent off to stay in a hotel for a few weeks. Now, they're very similar to what you see in airlines, and these are the ones we actually probably, this is the most commonly seen incident response plan you've probably encountered in your life. That and the little green man. That as an incident response plan is probably the most concise you will ever see. It communicates very, very quickly what you need to do when something goes wrong. Now, as application developers, we very rarely get involved in incident response. We tend to just be the people who get called somewhere down the line. But the thing that we can do, if we're going to bring together the team of 30 million and really improve software security, is have an application development-specific incident response plan. So what do we do as an app development team when bad things happen? Now, sometimes you'll find out about it yourself. You'll see it in the logs. But sometimes you're going to have a support team that comes to you and says, hey, a bad thing's happening. So let's do a little bit of a thought experiment. Somebody's rung the call center. Somebody's account has been hacked. Oh my goodness, there are suspicious transactions in this bank account. Raise your hand if you think this is a critical issue. All right, high, medium, low. I don't do security, it's someone else's job. There we go. I love a good, honest answer. What if we knew that, oh, hang on, we've got the person's name, they're coming through, Jacinda Adharan. She does something in politics. Does that risk assessment get any higher or lower? Oh, there's some politics happens in your head when I ask that. What if we then get a phone call 20 minutes later, it turns out there's 100 people who've got suspicious things on their account, and they're not all politicians? What if this grows to 1,000? They're coming in every few minutes. These kind of things, it's not your network team that has to respond to these. It's you as developers. You're the ones who need to understand, well, was it a password compromise? Is it something that bypassed authentication? What has been touched? How can we block access? We need a plan. Simple incident response plans are really formulaic. Identify a problem, verify it really is a problem and the scope of it, contain it, stop the bad thing from happening, and then remediate it, and then you loop between verification and remediation until you're fixed. Now, you might have incident response plans for platform issues, like outages. If you have one of those, expand it to include security incidents. Start with things like authentication compromises or outages, denial of services. Look at where your most sensitive data is and think about the worst thing that can happen. Have a high-level plan for that. And then, if you're a bit like me and you're a bit of a D&D geek, it's kind of the best kind of work. Because what you have to do is get the team together, and you have to play at this. You have to try it out. And I don't just mean the 2 people on your team who take care of risk. I mean, get somebody from your support team, get somebody from engineering, from ops, from security, and play it through. And if your plan says, oh, get the logs from X system, go get the logs from that system and see how much time you have. How hard was this? How much information do I have? And it's only by really playing this through will you understand if this is going to work when bad things happen. When COVID happened, we didn't have the plan on day 1 because it was new. But by a year in, that plan had been tested and tested and tested. Now, we don't want to have to do that for real. I don't want you to have a year of security incidents to get to your good security response plan. So you can do this in advance. So document that plan. Adapt from plans you already have, if you have them, and test it with a real team. And then you're going to be really well prepared that if bad things happen, you know how to respond and limit the damage. So whether it's tracing and knowing who you're connected to and how that spreads the risk, distancing, so keeping your sensitive things away from each other and protected, putting in controls to prevent things going between the high risk and the low risk, testing to identify issues quickly so that you can respond to them, prevention and patching and keeping up to date so that you stay safe in all of your technologies, not just the one you're working on today, and then responding effectively and consistently when bad things happen. If we did all of those things, even just a little bit each, as a team of 30 million, we're not talking about protecting your software that you wrote today. We're not even talking about protecting your team's software. We're talking about protecting an entire ecosystem. And that's what it's going to take to keep our system safe. It's not about us. We are just the little note on this entire course of technology. The only way we all stay safe is we all do it together. So I would like you to join the team of 30 million, and I'm going to ask you for two very concrete things. And it's not a sales pitch, so please note for the record. There's two important big things happening. The first I'm going to be really vague about. Just say watch this space in September, because we're doing something very big that's going to give you everything you need to get started, as a company, a non-profit, as an individual. And secondly, and I'm incredibly proud to announce, that SafeStack, my little company, we are a for-profit company, but we have a big purpose. And so from November, we are going to be providing free training to every single new software developer in New Zealand as an annual program. So from day one of their career, they're going to have that there. Now, what does that mean for you lot? Well, some of you are a little bit further on than that. That's okay. But these people are going to come, and they're going to come to you enthusiastic and caring about security. And so give them what they need. Support them to then nurture that new skill set so that it isn't just something that a few niche people come to conferences and try and harangue about. Help me to make myself redundant by embracing this new generation. So thank you so much for your time today and for having me here today, team. It's been an absolute pleasure. I'll be around all day to answer questions if anyone would like to talk. And if not, just find me online, lady_nerd on the Twitters, or Laura at ecosystem..Are. And thank you so much for your time today.